All right, awesome, guys. Welcome back to ArmanisMath. This is lecture number 7. This lecture is going to focus on the unit circle primarily. As a warm-up, it says convert from degrees to radians or from radians to degrees. How about a minute? I'm going to actually put a minute for you. Down here. Timer. 1 minute. 1 minute. Ethan? All right. So I see some of the chat messages. So we're going to start with the first one. You convert to pi radians by multiplying pi at the top divided by 180 degrees. Degrees are going to cancel, and that's going to leave you with 90 over 180. The zeros are canceled because there's the last zeros. 9 over 18 is 1 over 2. So the answer should be pi over 2. If you have doubts on this, a couple lectures ago, I went through details on these. So check lecture 5. This one here, you go from radians to degrees. And there's multiple thoughts on this. Probably the easiest is to think of this guy by itself first. Maybe this guy here. See that? Pi over 3. So I would say 2 times the pi over 3. Now, what is pi over 3? Pi over 3 is 60. 2 times 60. So you could say this is 120. That's one way to do it, right? The other way, obviously, is to multiply or you take the 2 pi over 3 multiplied by pi here and 180 because we want to get rid of the pi's, and we're going to come here. I have a pi obviously gone. 3 and 180, this is going to be gone. This is going to give you a 60. 2 times 60 is 120, and you are golden. 120. So it's either way. It doesn't matter which way you pick. Okay, remember, this is 2 times 60. This is 60 here. 2 times 60. All right, find the exact value of the trig function. This goes back to the triangles that we discussed multiple times. So check lecture number 3 and also check lecture number 4 on these items. But if you know that, please give me some in the chat. Some in the chat. Okay, I see that. Cosine 60 is 1/2. That is true. Sine 45, and I see that also. Square root of 2 over 2. Anyways, if you're not sure yet, please consult these 2 resources that I just mentioned. Okay. Here we go. Unit circle, one of the real-life application, real-world applications, is in designing, for example, bicycles like this. Or tires, for example. Mechanical and manufacturing engineers use it when they're designing bicycles, for example. Can you think of another example? Please put that in the chat. Any real-life example, you could put that in the chat. Or if you guys remember last time, we had you guys Google real-world applications. So anybody, feel free to chime in. Pizza, yes, we talked about that. Good job. All right. Objective today, you'll be able to understand and construct the unit circle. You will be able to understand and construct the unit circle. That's the goal today. Can you all please write me one word from the objective in the chat? All of you, please. Any word you like from the objective in the chat. Just want to feel that you guys are with me. You, okay, and unit circle. The, okay. That's funny. Okay. I see that. I see the understand and I see the construct. Okay. Now, here's the unit circle. This is what we're going to be after today. And my desire is for us to discuss it comprehend it, move on, so we can do some other things in trig. Okay, there's a lot of good plans that I have ahead, but we really have to master this. All right, that's the plan for today. We're gonna get to here today. Okay, here's the first thing, which is the 30-60. Before you do the unit circle, you really have to understand the special triangles. Why? Because they are so special. So special. No, it's because they help us in the unit circle. Yes, they are special. Just like me and you. 45. 45. We said in the unit circle, the desire is to have 1 as the radius. And if you have that, then you're going to have square root of 2 over 2 and square root of 2 over 2. If you're not sure how did I get this, please review lecture number 6. 30-60. 30-60 should be, excuse me, 30-60 should be like this. And this one, we're going to have a 1 because of the unit circle. And this one is half as much. This one is half as much times square root of 3 or square root of 3 over 2. Okay? Doesn't matter which one you do, but that's... How did we get these ratios? Please consult last lectures. Okay? At least number 5, I believe. Now, before I let go of this, can you give me some values, for example? So let's say I wanted sine 45. Sine 45. Let me give myself more room here. Sine 45. It's obviously, pick any 45 you'd like. Opposite of it is square root of 2 over 2 divided by 1. That's itself, which is square root of 2 over 2. Cosine 45. Feel free to chime in, by the way, in the chat. Same thing. The adjacent of me, if I picked myself here, I'm looking down here as adjacent, divided by the hypotenuse, which is itself again, because you're divided by 1, square root of 2 over 2. Tangent 45. Well, tangent says you have at the top sine over cosine or y over x. And in this case, because you have the same number here, the same number divided by itself, see that? You obviously can end up with a 1. Or you could do the 2 fractions, divide them, and then you have to do the reciprocal to multiply the second fraction. Things will be canceled out, and you end up with 1. How about here? Let's just do one of them. Let's say sine 30. Chime in if you'd like. I see some of you are writing things. That's good. Sine 30 is going to be, 30 is down here, by the way, because it opens up to the little guy. No! But 60 opens up to the larger guy. No! So 30. It is opposite over hypotenuse, which is 1/2. Cosine 30. By the same token, square root of 3 over 2. Wow, why did this look like that? Cosine. Tangent 30 is going to be sine over cosine, and it's 1/2 divided by square root of 3 over 2. We did that last time, but here it is again. You have 1/2 divided by square root of 3 over 2. You say this is 1/2 times 2 over square root of 3. See that? Which is 1 over square root of 3. You have to rationalize denominator. So this is 3. This is square root of 3, 3, and 3, which will lead you to have a square root of 3 at the top divided by 3 at the bottom. Square root times itself will give you the number under the square root. Square root of 5 times square root of 5 gives you 5. Square root of 3 times square root of 3 will give you 3. So that's what you've got for this guy here. Okay? Again, we've gone over this. We developed this one twice, I believe. Check lecture number 4 and 5. Any question on this one, please put that in the chat. Okay, here we go. Champions. My lovely unit circle. Okay. The unit circle is the circle of radius 1. Basically, they're saying this is 1. Let me choose a different color here. This is 1. Yo. This is a 1. This is a 1. And this is a 1. that radius. This length here is 1. Okay, so if this is 1, then obviously when I get to this point here, this is 1 unit. So this point is going to be, I'm going to choose different color for this guy, which is going to be 1, 0. Right? That's the point. At the top here, I'm going to have 0, 1. Negative 1, 0. 0, negative 1. All right. So it's because of this length here. This length is 1. It's a radius, and that doesn't change for the circle, so it's always 1 like that. Okay. Remember that you are centered at 0, 0. And that's basically the unit circle. See how beautiful that thing is? I love it. Oh my. It's really attractive. Okay. So let's take a closer look at the unit circle now. Okay, just a little bit closer. Let's zoom in a little bit. We are going to focus on this dude here. See this dude here? Okay. We said a minute ago that every x is cosine. I should say that was last lecture number 6. And every y is sine. Every x is cosine, every y is sine. See that? Every move this way because it's x-axis, move up is the y-axis. So if you were to write the let's say the point for this, there's a point obviously here. See the point here? So you're going to write this point. Well, you just have to say, what is that? Well, you just told us every x is cosine, every y is sine. So this point on the unit circle is cosine of that angle, whatever the angle is, and sine of that angle. Cosine and sine. So what about the tangent? Well, the tangent is always the line that is actually touching the circle. It says here, any point on the unit circle can be written as cosine of the angle and sine of the angle. So recall from your math life, if there is a circle, that's going to be, last time we said this is, let's say, 2, -2, and then 4. Okay? So this is x and y. Also, this thing, if you look closely at it, it's making an angle. This one is making an angle. Look closely here. This line is making an angle here. So if this is angle theta, you could represent that by saying this is cosine theta, comma, sine theta. And that's the beautiful thing about the unit circle. That's the beauty about the unit circle. The point, not just the Cartesian coordinates like in, I think it was 5th grade or something, a battleship if you played that. Not just the Cartesian coordinates, the points, but also you could represent as the angle. The angle is also another representation of the point. Okay? I'm trying to watch this chat at the same time, so please feel free to write things down. Important thing to know, if your unit circle, which is the truth, by the way, if your unit circle has a 1 as radius, wherever you go, it's just a radius of 1. Here's a radius of 1, wherever you go. Then this would be applicable here. That's why we said every y is sine. Well, how do you base that? What do you base that on? Well, in this truth here, y is going to be, sine is going to be y over x. So if you have your triangle like this is theta, this is your y, this is your r, right? So you're saying that y is y is the y is the opposite over the hypotenuse. Well, here's the opposite, which is y. And what's the hypotenuse in the unit circle? Can you chime in the chat? What's the hypotenuse in the unit circle? More people in the chat? Hypotenuse in the unit circle is always what? Yes, it's always 1. That doesn't change. That's why when you say sine theta, this sine, because you are in the unit circle, if this is 1, then it will say y divided by r, the radius, y divided by 1 in the unit circle. And that's why your sine is the y. That's why this guy here is the y. By the same token, obviously, cosine is the same thing. So cosine divided by x, that's why we say cosine is x. And tangent, we said it's opposite over adjacent. Opposite of me is the y, divided by the adjacent of me, which is x. Here's your y, and down here's your x, which is different colors for that. This is your y, and this is your x. So y over x. That's why you see it like that. Okay? Very important. So I would definitely wanted you to copy this down somewhere. So this is your x and this is your y, and tangent is tangent of theta, obviously, of that angle is the y over the x. Okay. All right. Let's play with this a little bit here. Let's start with the very simple one. I'm here in the unit circle, obviously, because the length is 1, the hypotenuse is 1, the radius is 1, and I'm at this point here. So I'm at 90, or pi over 2. We talked about that also. 90, so it says cosine 90. Basically, they're looking for the x part of your point. Sine 90, that's the y part of your point. So, and I see that here. See, some of you are putting that in the chat. So this is my x, and this is my y, believe it or not. This is the cosine. This is the sine. See the powerful thing about this? You don't have to use a calculator for this. The point itself tells you what is sine, what is cosine. So cosine 90 is going to be 0. 0 is the value, by the way. It's not 0 degrees. 0 is the value itself. Like 1, 2, 3. This is 0 as a value. Sine 90, which is the 1. And tangent. Okay. Tangent. That's sine over cosine. I'm going to write it down here. Okay. Well, what was my sine? 1. What's my cosine? 0. Oh, that's not a good thing. So it's 1 over. Really sad, please. Because it's undefined. There's no value for 1 over 0. We don't have a value for that. So that's why tangent 90 is undefined. Undefined. Okay. Tangent 90 is undefined. Okay, let's play with another one here. Why don't we think about, let's say, let's do it here. Okay, let's think about this guy here. Cosine 180, sine 180, tangent 180. Okay, let's play it a little bit here. Cosine. What's the point for 180? What is this Cartesian coordinates point? What is this rectangular point? -1. Thank you. Comma 0. I see that in the chat. So -1 comma 0, well, I basically just have to put that here, -1 comma 0, and just start to play. I mean, come on. It's there in front of my face. Didn't even touch calculator or anything. Cosine, we said it's the x part, which is the -1. Let me make that. Sine is the y. Okay, that's the 0. Tangent is y over x, or cosine over sine. I'm sorry, sine over cosine. Sine over cosine. Which in this case, sine is 0. Okay, divided by 1. I'm okay with that. 0 at the top is fine. There's nothing wrong with that, because it's going to give you 0 as a value. 0 as a value is definitely a good thing. It's not a bad thing. Okay. 0 is good. And if we're going to go to engineering, particularly computer engineering, software engineering, you will love to chase zeros. Zeros and ones in that matter, for that matter. Okay, guys, so that's how you do that. Any questions on 90 or 180, please say something in the chat. All right, so here we go. Now we're going to apply what we know about what we the previously mentioned facts. For example, we're going to apply the 30-60, the 45-45, and also the corner points or the quarter points, which is 1, 0, 0, 1, and etc. So if you are here and you like me, sometimes I like to graph things. So this is my first. This is my first. Low. This is my first, which is the 30. All right. So at 30, if this angle is 30, which is in this case 30, I want to know these here. Well, you know these here by looking at the 30-60 triangle. As simple as that. As simple as that. So I'm going to go back to my 30-60 and See, what was the ratio? If this is 1, which is true about the unit circle, the radius is 1. This is a half. This is square root 3 over 2. This is the 30, and this is the 60. 30 sings a little bit lower than 60. 60 has a higher pitch in singing. No! 30s. No! So now let's talk about the sine and cosine. So cosine, sine. Maybe I don't need tangent, but it's just there. Okay, so cosine of this guy is going to be what? Do you guys remember? Cosine is going to be the adjacent divided by the hypotenuse. Adjacent of 30. Oh, let me put that thing in the blue. Adjacent of 30 is the square root of 3 over 2. Hypotenuse is 1, which means you are dividing it by 1. That's square root 3 over 2. Okay? And by the way, cosine, we also said cosine is what in terms of x and y? Does anybody remember? Well, what's cosine in terms of x and y? Cosine. That is very true. Thank you for fixing that. So every cosine is x. Okay, every sine is y. So I would actually now make my point, my own point. I'm going to say this is square root 3 over 2, comma, and then I'm going to say sine. What is sine 30? Well, we said sine is the opposite over the hypotenuse. What's 1/2? 1 over 2. So the sine is 1 over 2. This is y. This guy is x, and this is y. This is cosine. Cosine, this is sine. So how do I do that? Well, you just take the point that you just had right now. You worked hard for this point. See that? You did, right? So you're going to take it exactly the way it is. And we'll see this triangle here, this triangle. We're going to just copy and paste it. You're going to take this dude, put it exactly where it belongs here. 30. This is the 30 triangle. It is the 30. And then also we're going to take the point itself that we worked hard for, this one here, and we're going to take it and just put it here. This is exactly the point. And now that's why you see here that cosine is square root of 2, sine is 1/2 of 30. Okay? Any question on this? Any questions on this? All right. So I am going to move on, and I'm going to actually do the 45. Let's actually do, yeah, I'm going to do the 45. Let's do the 45. I'll come back to this dude here, but let's do the 45. Okay, the 45. I'm going to have to start a new one. The 45 is going to have me do the 45 triangle, because that's the value I'm going to use. I'm not going to invent numbers. This is exactly what I have for the special. They're also special. It's a special triangle. This is 1. This is 1 here. And this is 45. And this is square root of 2 over 2. Square root of 2 over 2. Okay, so now we're going to start with cosine. Leave myself a little bit of room here. Sine. And then tangent. We did not really use tangent, but it's just there if you want to use it. 45 in this case. 45. A lot of you on the, I shouldn't say a lot, but some of you in the homework, in the assignment that I gave, you guys forgot to put 45. So you're just saying tangent something equals, you make sure that you put the angle that you're talking about. Okay. Anyways, back to this guy. We said cosine is x, just for my brain to, for sanity check here. So I'm expecting to see an x and y here somewhere, which is I'm working towards here. Okay, let's see. Cosine 45. Cosine 45, if I picked myself being here, this is my eyes looking, and I am looking across here. Wow, that's my eyes. Are you sure? That's my eyes. My gosh. Maybe my eyes are like this. My eyelashes. So this is your perspective here. You're looking from this side here. Okay. And cosine is adjacent. Adjacent of me is this down here. Square of 2 over 2 divided by 1, which is going to give me square of 2 over 2. Sine is opposite of me, which is square of 2 over 2, again, because it's divided by 1. That's just itself. Square of 2 over 2 divided by 1 is just square of 2 of 2. Now for tangent, tangent is y over x, or sine over cosine. Sine over cosine over cosine. And we just figured out the values for both of them, which is square of 2 over 2 divided by square of 2 over 2, which is just a 1. So I'm here trying to fill up this point. This is square of 2 over 2. This is square of 2 over 2. Guess what? What do you think we're going to do? Copy, paste. Copy, paste. Copy, paste. Copy, paste. I will take this 45, copy and paste it here. This is the 45. See that? This is the 45 triangle. See that? Yeah, that's 45 triangle. So, and what you get the points from? Well, the points, we got it just right now. We worked it out. We spent too much time working on this thing, and it was worth it. Look, I'm going to take this point exactly the way it is and put it exactly where the 45 on the unit circle belongs, which is square of 2 over 2, square of 2 of 2. Okay? I'm not going to develop the 60, but you got the idea. For the 60, you do exactly the same thing. Unless if you want me to, put that in the chat. Otherwise, we're going to move on because we're going to take a look at cool stuff. Come on, cool. Okay, anything here? What about tangent? Okay, let's go back and see. Somebody's just asking, what about tangent? That's no problem. Tangent here is 1. So for 45, tangent is 1. You take this one, the y. You take the x. Tangent is y over x, as we said here. Y over x, sine over cosine. It's going to give you 1. Yep. For whoever was asked that question, that's how you get the value of 1. Okay, to the unit circle we should go. I also remember last time we shared, don't forget this kind of mnemonic, I guess, that we use in math, that all students take calculus. All student take calculus. Okay. This helps you a little bit and remember these, the sign. Is it positive or is it negative? And I know and I like all students take calculus, but let's say that you forgot it. If you forgot it, it's not a big deal. As I tell my students always, you just pick a point in this quadrant. For example, I want to know here. Okay, pick any point on this quadrant. You are moving into the negative x, right? And you are moving, actually, you are in this side is the positive y. Anything here is going to be negative x and positive y. For example, can somebody in the chat give me just any point in the second quadrant? Any point here? Any point in the second? Yep, negative 2, 1. That lives here. And that actually tells me, if I looked at the point itself, I don't even have to remember, oh, student take out. You don't have to. You could just look at the point. Look at the point, man. Look at the point. And the point here is very clear. This is negative x, which is negative cosine, by the way. And this is positive y, which is the sine. Now, how about the tangent? Well, come on. Tangent is the y over x. And in this, I'm looking just to see if it's positive or it's negative. Because one of them is negative, the tangent will also end up negative. Okay? Tangent will be negative in the second quadrant. All right, second quadrant. Anyway, so I'm not going to spend too much of the time on this, but you've got the idea. You will get to see that this is positive, negative. Give myself a little bit more room here. Negative, positive, negative. The third sign, by the way, was for the third sign. The third positive or negative sign was for the hello, come on. Was for the tangent. Okay, and this one here is going to be negative cosine, negative sine, but it's going to be positive tangent because negative over negative is positive. The last one here is going to be a positive cosine, negative sine, and negative tangent. All right. Anyways, so we're here. So maybe you could say all. Then you could put student here if you like, all student. And let's talk about this a little bit here. If you remember, I said I'm not a big fan of memorizing things because in math it's really hard to memorize things. Remember, in math you really have to understand the concept, otherwise you'll be lost. If in math you're just memorizing things, there will be some hurdles in the way and it's going to get you. So you really have to understand the concept here. I don't want you to memorize things. Okay, so we did the 30. Together we did the 45. Last time we did the 60. And all what we have to do now, you guys, is to know where are you at in the unit circle. For example, the 30 here, this 30, has a reference angles, obviously, of 30. Right? From here to here is 30. Which is exactly the same reference angle if you come here at 150. 150 has a reference angle of 30. Remember, the reference angle is whatever takes you to the closest x-axis. Whatever takes, how much takes you to the closest x-axis of your angle. Okay, so 30 is 30. That's why it has the same. If it has the same reference angle, it will have the same value with one exception. Is it positive or is it negative? And that's when all student take calculus come into the show here. So you know it's going to be the same as the 30, with one exception again. Is it positive or is it negative? Well, this is easily decided by if you know all student take calculus. The only thing that is positive in this quadrant is the s, which means the sine. So cosine has to be negative, sine has to be positive, tangent has to be negative. So I'm going to come here and then edit this. See this here? I just edit that. Same thing, but I edit. Is it positive or is it negative? And that's how you know. All right. That's one way to do it. The other fun way to do it, I think for me, I'm going to call it fun, is actually to use your geometry brain side, which means the reflection and the rotation and things. So I would come right here, and then I'm gonna, for the 30, for example, the 30 is an exact reflection of 150. Wow. So if you actually, if you take the unit circle, which is actually half of it right now, if you take the top half and you fold it just like that on the x-axis, reflection on the x-axis, symmetry on the x-axis, just like that, you will find out that you're landing on the same spot because of the reference angle. This guy here is going to land exactly on the same spot as this guy here. It will land on the same spot. Okay. Now, what about 45? Well, what do you think? 45 is also going to reflect itself, and 45 is going to be exactly like the 135. 135. Okay. And 45 is going to be reflected over 135. And also, what did you think about the 60 here? Chime in in the chat. What do you think about the 60? What's the reflection of 60? Oh, come on now. Well, yes, that is reflection of 60. If I started here, I just fold symmetry over the y-axis. I'm going to land on 120. The 120 is a reflection of the 60 vertically. Okay, and that's why it has the same value. If you guys remember, with one little exception, is it positive or is it negative? And you know this by knowing all student take calculus, or by you picking any point in that quadrant, any point you like, negative 100, comma 560. So it would work. It would work. All right. So that's what we do on this side here. Also, another thing I wanted you to look at closely, just a little bit. I mean, this is going to add a little bit. Look at this number here. This is 1/2. See that? Look at this guy. This is square root of 2 over 2. Interesting. Look at this guy. Square root of 3 over 2. Very interesting. So if I said this is square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, how much do you think this guy's going to be? Square root of what? Square root of 4 over 2. Interesting. Hold on, Armani. Square root of 4 over 2. Oh, square root of 4 is actually a 2. 2 over 2 is 1. Look, you are looking at 1 here. Whew. Oh my gosh. Oh my gosh. Okay. Also, you could move this way with that concept. You also could move the other direction, the other rotation. You could actually move from 0, and then 1, and then square root of 2, and then square root of 3, and then square root of 4. See what I'm talking about? Here, you also could start with 0, square root of 0 divided by 2. Square root of 0 is 0, over 2 is 0, and that's why you have 0 here. See that? That's why you have 0 at the bottom here. That's why you have this 0 here. Okay, that's one way to helpful to make things sink in just a little bit. Okay. Also here, a good thing about symmetry. This is a symmetry over the x-axis as well. Believe it or not. Believe it or not. Meaning, here, this guy here is actually a reflection. This guy's a reflection of this guy. So you take the unit circle at the top, fold it over the bottom. Basically, you're folding over the x-axis. If this is true, then you're folding it like this. And you're going to get the same point. Hello. Same point. Hello. Same point. Look, same coordinate points. With one little exception, right? Where are you in the unit circle? 1, 2, 3, 4. Oh, interesting. All students take calculus. Only the cosine is positive, which is true. The cosine is positive. That is this positive here. This guy's positive. And everything else is negative. The sine and also the tangent. Okay? So you actually could also use it with reflection. Here's another one if you want to think of it also that way. And obviously a third one is this way here as well. Okay, so you reflect over the x-axis, you reflect over the x-axis, or reflect over the y-axis. You have a symmetry on the x, symmetry on the x, on the y. You also have a an x and y reflection, basically, is what we're talking about here. So this is it. This is the unit circle. It's all in its beauty. I talked about today, we developed the 30-60. If you guys remember, we developed the 30-60 triangle. We talked about the 45-45 also triangle. And we talked about the 60. We talked about the first quadrant. That's what we started with. And then we talked about some mnemonics to help us remember. You don't have to, but they're just there to help you, which is all student take calculus. We also talked about the reflection and the reflection. Let me change color. And also the vertical symmetry and also the horizontal symmetry as well. Horizontal and then vertical symmetry as well. Like, for example, this guy and 5 or 6. Okay, that's the beauty of the unit circle. So let's quiz ourselves here and see what's going on. Find the exact value of a trig function. Please do not use calculator, obviously. Calculators gives you approximate, not exact value. So we're gonna let's just start with this one. What is 2 pi over 3? If you guys remember that, we've done something similar to this earlier. 2 pi over 3. What is 2 pi over 3? In the chat, 2 pi over 3 would be how much? 120. Thank you. So what is cosine 120? That's the thing right now. They're asking us what's cosine 120 basically. Cosine 120. How much is that? Cosine 120. Look at the unit circle. I'm just going to go back one slide. 120 is here. 120 is here, right? And cosine of it is just this guy here. That's the x part of it. So cosine 120 is negative a half. Okay, negative a half. Yeah, I don't know about you, but I found it a little bit easier to think of angles in terms of degrees first. So 120, cosine 120, which is 1/2. So it's up to you. If if your capacity in your brain are able to just use the pi radians, all power to you. That's fine. If not, then I would convert it to degrees first, and then find out the corresponding value for that. Okay. How about sine pi over 4? What is pi over 4 to start with? What is pi over 4? Well, that's pi. I took my pi, sliced it in 4 pieces. 180 divided by 4, that's 45. So we are talking about sine 45. 45. Sine 45. How much is sine 45? That's a square root of 2 over 2. Okay. How about this dude down here? How about 4 pi over 3? My thinking is interesting. I could just deal with this here, this piece here, which is pi over 3. It's 4 times the pi over 3. Well, what's 1/3 of the pi? That's 60. 4 times the 60. How much is 4 times 60? 4 times 6. How much is 4 times 6? 240. Thank you. So 4 times 6 is 240. Basically, they're asking what is tangent 240 degrees. And how much is tangent 240 degrees? I have to look because I forget things. 240. So I'm going to go back to my unit circle and see what is 240. 240 is down here. It's down here. I'll give myself more room here. 240 is this boy down here. See this boy here? Tangent. Tangent is going to be this guy, which is the y, divided by the x. So basically, I'm going to say square root of 3 over 2 divided by 1/2. Okay? That's a square root of 3 over 2. You just have to play with the fraction. So square root of 3 over 2 times 2 over 1. The 2 is going to cancel. That's going to give you square root of 3. Yeah. Please double check on your chat if this value is true here for tangent of 240. Check for me. Give me a thumbs up if you think it's okay. Not, like, we could fix it. Tangent 240. Is this true? Square root of 3 over 2 divided by 1/2. Square root of 3 over 2 times 2 over 1. The 2's are going to cancel, leaving you with square root of 3. Okay, check it out for yourself. And then cosine 2 pi. Well, come on. I don't even have to go back there. 2 pi is this guy here. This is 2 pi and 0. Remember the coterminal angles? This guy's here is a 1, 0. Cosine is just the x part of it. Excuse me. It's just this guy here. So it's going to equal to 1. All right. Cosine is going to equal to 1. Okay. And what else do I have to do here? We need to find cosine of 135, which is 45. So basically, you're here. For 145 is here. You're here. And 45 always has a square root of 2 over 2. And because it's the second quadrant, it has to be a negative. Tangent 270. Well, tangent 270, you are down here, boy. 0, -1. -1 divided, this is a y over x, if you guys remember y over x. -1 divided by 0 is going to be -1 over 0. Very sad. No value for this. Undefined. Interesting. Okay. Well, okay. Well, as always, there's a minute of hope with Armani towards the end. No matter what we're going through, remember that we are here for each other, okay? So do something that makes somebody smile today. Also, remember that around us in town, there's a big poster sign and all over. Give help, get help, okay? It's not just like you're trading things, but you're nice in terms of just being yourself and appreciating what people around you are doing. Also, perhaps we need to remember those who have suffered during this time. So think about them, pray for their family, for loved ones. It's not easy times right now, but I still believe with you that there is hope. God is going to take care of us. We're going to pass this rough period in our lives. Take care of yourself. Sometimes you think nobody understands you, or you're hurt from inside and nobody's paying attention, but there's always one person who does, and he is beyond us as human. He takes care of all of us. God is awesome. Okay, guys, you guys are awesome, and I'm happy to be with you today. All right. Towards the end, if you have any questions, please write them down in the chat. Love you too, guys. Moshi moshi. Watch, subscribe, smash the like button, and share with somebody who might benefit from this one. Okay, guys. Love you guys all. Okay. Have a great day. All right. Take care of yourselves.